Hey guys, Mr. Carter here. Going to be the lecture notes for 1.1. There will be one of these videos for every single subsection of every unit. So you're going to get used to hearing and seeing me quite a bit. Unit 1 has 7 sections. This is section 1. Every unit has 3 big ideas. These are the 3 of them. If you look in your digital notebook, they're all sitting there for you as well, and you will be answering these questions at the end of each unit. So these should be a focus to kind of make sure this is what we're picking up and learning after we're done with the unit. So I'm not going to go over them, but you will see this slide in every single PowerPoint that we do for every single subsection, for every single unit all year long. So this is kind of a pretty traditional one we're going to be looking at. So geography is a field of study, and this is kind of before we get into 1.1, just kind of a little bit. Geography is the study of earth writing. So it's all about kind of what's happening on the earth. And there's 2 different types of geography. Physical geography, which is maps and weather and climate, kind of the basics. And then there's the other half, which is human geography, which is what we look at, which is kind of how humans impact Earth. So really we look at the why of where. Why are things where they are? How did things become distributed or laid out the way they are? What is the changing pattern of distribution? What are the implications of the spatial distribution for people? Why are certain things happening in certain places but not others? All of that is kind of what we end up looking at in this class. We're not going to start that till Unit 2 with population. Unit 1, unfortunately, is extremely boring. It is the background basics of what we need to know. So because of that, we're not going to kind of be looking at this stuff quite yet, but we're going to be looking at the tools we need to understand how we do this. So we look through the lens of space to understand a place. So space is kind of everything that's around you. The place is how they make that space specific. It's a kind of confusing concept. It'll be easier to understand as we kind of go through and we try to figure out places. But it's kind of what makes things the way they are, where they are. So introduction to maps. So we talked about kind of one of the things we have to understand is why things happen where they happen. So one of the subsections of 1.1 is that you will understand that geographers use maps and data to depict relationships of time, space, and scale. First thing you need to identify is there are 2 types of maps and kind of what we can learn from these maps. First types of maps are reference maps. These are designed to refer to for general information about places. Political and physical. Political maps show you boundaries and state names. Those are the typical maps you look at. Physical maps, mountains, rivers, roads, deserts. These are kind of the traditional maps you look at in your life. Looks like these here. These break up things like a political map, break up things where political divisions happen. However, what we really look at is going to be thematic maps. And these are what helps tell the stories that we're supposed to kind of understand. There are 5 primary types of thematic maps. We're going to go over them now. There's also a handout on these in your digital notebook. Choropleth map uses various shades of one color or pattern to show the location and distribution of a phenomenon or data. Usually the darker the color, the higher it happens, but this is not always true. All of these maps have a key. So if you look down here in the bottom right-hand corner where my cursor is, it'll tell you the number of fatalities per 100,000 people when it comes to motor vehicle deaths. And if you look, the darker, the more that happens. Now, this is a choropleth map. At some point when we start looking, we're going to have to start trying to analyze why is this happening where it's happening. And that's kind of more of what we'll be doing in later units. But no, this data is not just for us to look at. It's for us to kind of to make assumptions and learn things from. Second type of map is a dot map. Usually what happens is for this one, it gives you 1 dot for every certain number of things. So it's used to show the specific location and distribution of something across the territory of the map. Each dot represents a specified quantity. So for this particular one, we look at the map, it says one dot represents 100,000 people. Here's what you need to remember. If we look at these blank spaces, let's say we look at here in the central United States, does that mean nobody lives there? The answer is no. What it does mean, though, is these locations, either city or county, do not have 100,000 people, so they don't meet the necessary threshold to get that dot. So people are there, but just not enough people. The other thing we look at is, what can we learn from looking at this map? If we look at this, what do we see? That one, majority of the population is coastal, right? If you look at all the maps, very little people live inland. Almost everybody lives somewhere near a coast. This is not by accident. And we'll get into that more. But a lot of what we do with these maps is we're looking and we're trying to understand a pattern that's here. Graduated symbol map. The larger the symbol, the more frequently it happens. The smaller the symbol, the less frequently it happens. Map key determines the exact amount, and it just tells you very quickly. You can just know that Texas and California use a lot more of it than, I don't know, Montana and Idaho. So if just by looking, it gives you a quick assumptions or kind of something you can learn. Isoline maps, we are not going to use these very often. ISO is Greek for equal. A line is they connect each other. Typically, we see these with two different types of maps, weather and elevation. So really what this means is if you followed one of these bands around, let's say this big one that says 8,400 right here along this lake, if you follow this band around, everywhere this band touches is exactly 8,400 feet in the air. That's all it means. These maps are very hard to read. The closer the lines, the more frequent the intersections or kind of the changes happen. So you can tell mountain peak versus valleys below. But once again, not a map we use very frequently. A cartogram map, also another one we don't use frequently. This distorts the shape and the size of the things on the map according to that data. So these two maps right here, this one references immigrants, so people coming into a country, and the next slide is immigrants with an E, and that is people leaving a country. Terminology you're going to need to know when it comes to migration, introduce it now, but immigrants with an I, think of IN, and immigrants with an E, think of E exit. But if we look at these maps, look at the United States, the first map in the United States is very large compared to, say, let's say all of Central and South America. Why? Because this is the number of people coming into the country. United States has a lot of people coming into the country. The next map, which shows people leaving, we'll see United States is very small compared to Central and South America. And the reason why is we have less people leaving the country than these people do have coming, than these people do have kind of the opposite. So the bigger you are, the more that they're leaving. The smaller you are, the less they're leaving. But that is in reference to the size of what it should normally be. So these maps are really hard to kind of analyze in isolation because the references are only comparison references. So they're harder to do. We don't look at very many cartograms. They're just not highly effective for what we do. So the three primary ones, I'm going to go back. The three primary ones we're going to be looking at this year that you're going to see frequently are these three. A choropleth, which is, I guess, probably about 85% of every single map we look at is going to be a choropleth map, a dot map, and a proportional symbol. The dot density or dot map is probably the second most popular, with, like I said, the most popular one being that choropleth map. That's the one we're going to see all the time. So types of spatial patterns represented on maps include absolute and relative distance and directions, clustering, dispersal, and elevation. So what do these terms mean? So when we look at maps and stuff that's represented there, these are the terms we're going to be looking at. So absolute and relative distance and direction, clustering, dispersal, and elevation. Absolute location is the precise spot where something is according to some system. Most widely used longitude and latitude, and then your physical home address. Your address that you write down, the school address, 23100 Cougar Canyon Road, that is an absolute location. Provides you a specific pinpoint on a map. The second side of that, well, here, let's keep going with this. You have latitude and longitude. Latitude lines labeled north or south. Longitude lines are labeled east, west. I'm not going to remember latitude and longitude. I've taught this class for 13 years now. Still don't remember them. Everyone is 15 degrees apart from the next line, and it represents precise locations. So know this. You're going to have to know it. Latitude, distance north or south of 0 degrees are called the parallels. Why? Because they run parallel around. Notice that each line is 15 degrees north or south. The lines are not equal. Sorry about that. They get shorter as they approach the north and south poles. That's because the Earth is spherical. If you think the Earth is flat, you're in the wrong class. And you need to think about that a little bit more because the Earth is not flat. The longest line of latitude is the equator. This complete middle of the Earth, the circumference of it is the widest there. Longitude, distance east or west of the 0 degrees. They're called meridians. The cool thing about these, and one of the reasons why longitude is so important, is every 15 degrees of longitude represents a change in time zone. Every 15 degrees represents an hour. So if we think about like Eastern, Central, Mountain, and Pacific Standard Time, each of those are exactly 15 degrees apart from each other. So if you think about Pacific Standard Time to Eastern Standard Time, there's a 3-hour difference. And that's because we're changing degrees of longitude. That changes our time zones. So this one, not super important. So relative location is where something is in relation to other things. So if we think about this normally when I'm on campus, I would say, where is our classroom in relation to your other periods? That is relative. So relative location changes all the time. The Target is next to the PetSmart, or Best Buy is across the street from it. That is relative to where you are. That if I didn't live there, if I didn't know the location, it wouldn't work. So if I told you the middle school is next to the high school, that only works because you know what high school I'm talking about, so therefore you can reference the middle school. Ideas like that are kind of specific to each individual person and that location where they are at. So relative location can change over time as accessibility changes. Ghost towns. They were once next to water sources, trade routes, or near mines that have closed up, which means that town kind of ceases to exist. They lost their relative location. They lost that advantage of that location, therefore they did not sustain. So like I said, relative location changes significantly as society changes. So map scales and kind of way we represent maps on kind of how maps work. Maps are a reduction of the actual land it represents. A world map is not the size of the Earth. So scale is the ratio in betweens. There are 3 types: cartographic, geographic, and scale of data. First one is the map scale. So written as either kind of a fraction, lines. So there's words, 1 inch equals 10 miles, ratio 1 to 200,000, or 1 unit on the map equals 200,000 units on the ground. That could be inches. So we see it right here. Line, the length of line. Note that the smaller the scale, the larger amount of the area that is covered. It is kind of counterintuitive. Large scale map means you're looking at something very, very closely. Small scale map means you're looking at a large amount of area. You are going to have to know the difference of these two, and that is kind of the key part of cartographic scale, is that you understand small scale and large scale. So for cartographic scale, there's 2 important things to know. One is how we represent these things, which is the first 3 bullet points. And the second one is small to large scale. This is normally confusing. It is just opposite. So if you look at fractions, 1 to 94 million over 1 to 1.3 million, 1 to 94 million is the smallest scale because it's the smallest fraction. If you look at the numbers, large scale gives you more detail than small scale. And like I said, these are important to understand and know. Okay, so we talked about cartographic scale. The next type of scale we're going to look at is geographic scale. Essentially, with geographic scale, it is the territorial extent that a map is representing. So if we're looking at a world map of data, that's a global scale. If we're looking at a group of countries, that might be a regional scale. All the way down to like a local scale map, which would be like cities. So from there, we can analyze the data at that geographic scale for that map. So what we'll end up doing is with the geographic scale is we'll be looking at a lot of choropleth maps or dot density maps, proportional symbol maps, or cartogram, and one of the first things we'll ask is, what's the geographic scale of this? Are we looking at the globe? Is it a global scale? Are we looking at a country? So it's a state scale. That's kind of what we need to figure out. And so that's what geographic scale refers to when we start referencing kind of geographic scales of maps. Scale of data. Scale of data is when we're looking at data between two different scales and kind of what's there. So if we look at the two maps of Australia, the scale of both maps is the same, but the data is different. So here we have a map of all of Australia. It shows the population density somewhere between 5 and 9 people per square mile. It turns out Australia, nobody really lives there, particularly in Western Australia. However, once we change that scale of data and we start breaking it down by Australian states, we start seeing that there is a significant difference. That down in Victoria, it's much higher than Western Australia, where it's the middle of the desert and nobody lives there but gold miners. So the reality is, when we change our scale of data, we learn something new. It doesn't mean that this is necessarily untrue, it's just true at this scale. Whereas this scale, this data is true at this scale. I hope that makes sense. And the scale of data we look at is extremely important for kind of understanding what's happening and not happening. You also have to realize that when we start analyzing these maps with data, this is a snapshot. So this data is true for this event, this time, and we can make some assumptions, but they don't always hold true. And this is something we'll be doing more as we start kind of getting into stuff in class, particularly with units 2 and on. We start talking about population and stuff like that. But just know that data is only valid for what we're looking at, and we can't really transpose that data someplace else. It becomes much more challenging. Clustered versus dispersed. These are as simple as they sound. Clustered means they're put together. Dispersed means they are separated apart. So this just happens to be the way things are. City clusters, which you're seeing here. Cities with at least 1 million people. We see some clustering in Asia, particularly East Asia, South Asia, China, India, Europe, and that's about it. Major population centers. Otherwise, we don't see populations pretty dispersed from there. Here you have clustered. Here you have dispersed. Visual graphic image, but it kind of gives you the idea of what we're looking for there. And then the other thing we can look at map is elevations, and this is where you get, this one's a choropleth map. The different colors tell you above and below sea level. We don't look at these a whole lot. We don't look at elevation a whole lot in general. So, move this out of the way. Let's go back. All maps are selective in information. Map projections inevitably distort relationships in shape, area, distance, and direction. So when you look on a map on paper, that's called a map projection. The minute that globe goes from round to flat, we're now projecting it down onto a piece of paper. We are going to distort it, and that is because the spherical, kind of roundish Earth does not transfer down to a two-dimensional piece of paper. So the minute we do that, we distort something. It's either in shape, area, distance, or direction. And there are hundreds, if not thousands, of different types of map projections that all attempt to kind of distort something different for different purposes. So if you were to drive this onto and transfer it over, very similar, right? We would draw this through grid lines to copy. You draw a grid line on an Earth, it doesn't work. So these distortions all cause issues. So shape, area, distance, and direction. Understand that every projection has distortion, but they all typically keep to maintain one part of SAD the same, or kind of not distort one in kind of shape, area, distance, or direction, so that map can be useful for something. Mercator projection. Purpose is navigation. They are accurate lines of latitude and longitude that meet at right angles. The distance between the lines of latitude and longitude appear consistent. Land masses near the poles are larger. This is perfect for navigation, because if you hop on the line of latitude or longitude that you need, and you can plot degrees and you can travel where you need to go. However, shapes are distorted significantly. Greenland's not anywhere close to being that large. You have problems with that. Peters projection. Spatial distribution related to area. So the area is accurate. Africa has a lot of land area. So the sizes of land masses are accurate. The shapes are inaccurate, especially near the poles, because it elongates them, but they give you the sizes. So look at here. This says that the size of Africa is like this, significantly larger than South America, almost all the way up if you think about size of land mass. If we go back, look at how much smaller Africa seems. I will tell you, most maps you look at are the Mercator projection. For us, that's not going to be the case, and it depends on what we're looking at. Projection. So here you're seeing the Peters projection over the Mercator. So you can see the differences. I mean, look at the sizes of Africa, of South America. So there's distortion here that has to be maintained for something. Conic map, general use in mid-latitude countries. Lines of longitude converge, lines of latitude are curved, size and shape are close to reality. Directions are not constant. Longitude lines converge at one pole, which means you can't use this for navigational purposes. Good Homos line. It's good for showing spatial distribution. Area and shape are preserved. It interrupts the oceans. They're not continuous land masses, which doesn't work. But this is kind of like, say you took a round ball and you cut it apart. It's kind of what this one is. Robinson projection. Size is closer to accurate. Ocean sizes look more accurate. Antarctica looks very large and Greenland looks flattened to the north. Robinson kind of is the... Robinson distorts a little bit of everything to be as accurate as possible in all areas. And that is it for Unit 1, Section 1.